Hi everyone, this is Clark Towson. I'm a retired computer scientist and former defence supercomputing specialist. You likely know me as the creator of the Westgate Bridge livestream, which monitors one of Melbourne's most important transport bottlenecks in real time. For years, people across Melbourne have lived with traffic congestion, truck movements, freight pressure, road noise, travel delays, and the impact of major transport decisions. People could feel the pressure, they could see the trucks, they could sit in the traffic, they could hear the noise. But most people could not easily see the numbers behind it. And that is where this project began, with a simple question: what does the data actually show? Over the past few months, I've been applying my background in high-performance computing, large-scale data processing, transport monitoring, and AI-assisted analysis to Melbourne traffic and freight data. And the result is one of the most detailed independent traffic intelligence projects in Melbourne. And this project brings together two major layers of transport data. The first is SCATS, traffic signal data from intersections across Melbourne. The second is TIRTL, vehicle classification data that helps identify trucks, freight movement, vehicle types, and corridor pressure. Together, they help turn raw traffic records into something the public can actually understand. Not opinions, not guesses, not political talking points, actual observed traffic and freight statistics. And the challenge: building this was not simple. This was not a small spreadsheet. This was 12 years worth of records. Billions, that's billions with a capital B, billions of observations, thousands of monitored locations, traffic signals, vehicle movements, truck classifications, maps, charts, scripts, dashboards, suburb summaries, corridor rankings, and processing pipelines. Now, not long ago, analysis at this scale would have required a government department, a large consulting firm, a university research group, or a dedicated technical team. But the world's changed. This project was built independently, by me. It was AI assisted. It was built with open source tools, programming, automation, mapping, data engineering, and persistence. Done by one person, as I say, it was done by me, working from a basement in Spotswood. And that's not because the work is small, it's because the tools have changed. AI has changed what one person can do. Open source tools have changed what one person can build. And public data has changed what one person can reveal. Now, what can you explore with this? The SCAT statistics help show Melbourne-wide traffic patterns across years of records. People can explore busy intersections, suburb rankings, peak periods, daily and yearly trends, corridor pressure, quiet periods, COVID recovery patterns, and how movement changes across the week. The TIRTL statistics add the freight layer. They help show truck movement, heavy vehicle exposure, freight corridors, truck share comparisons, suburb truck pressure, and where commuter traffic and freight pressure overlap. So this is not just about where traffic is heavy. It's also about where truck and freight pressure are concentrated. It helps reveal the places where daily commuting, industrial traffic, port access, freeway pressure, freight movement, and local community impacts all come together. Now, why does this matter? Well, transport decisions affect everyone. Residents living beside busy roads deserve evidence. Communities dealing with truck traffic, noise, congestion, and safety concerns deserve evidence. Small businesses affected by freight routes and travel delays deserve evidence as well. Journalists should be able to ask sharper questions. Researchers and students should be able to explore real-world transport data. Councils, planners, government departments should have better public-facing information. And ordinary Melburnians should be able to understand what is happening on the roads they use every day. Now, for too long, traffic data has lived inside systems, reports, departments, and technical documents that most people never see. This project is about bringing some of that evidence back into public view. Now, this project is being released as a free public service. The statistics are available for people to view, use, share, question, and build upon. The code behind the project has also been released on my GitHub, so people can inspect the methods, understand how the analysis was produced, and improve or extend upon my work themselves. Now that matters because public interest data projects should be transparent. If numbers are going to be used in public discussions about traffic, freight, roads, planning, and local communities, then people should be able to see how those numbers were created. The aim is not to lock the work away. The aim is to make it useful. Now let's talk a little bit about the Department of Transport. This work is not about replacing the Department of Transport. The department has responsibilities, expertise, systems, infrastructure, and access that an individual does not have, access that I don't have. But independent analysis can still play an important role. It can make public data more visible. It can ask different questions. It can show local communities what is happening around them. And it can help create a more open, evidence-based conversation about traffic, freight, roads, planning, and the future of Melbourne. Now, this project may also be useful to the media. Traffic, trucks, freight, congestion, road pressure, planning decisions, and local community impacts are not abstract issues. They affect people every day. And media organisations are welcome to use my work to publish stories, investigate transport issues, compare suburbs, analyse truck movements, explain local traffic problems, and ask better questions about Melbourne's road network. The statistics, the charts, maps, suburb summaries, and corridor findings are being made freely available for public reporting. I only ask that the work is used fairly, accurately, and with appropriate acknowledgement. Now, this is not just a one-off report that I've created. It's a system that I've developed, a system capable of generating transport stories now and into the future. So, I've now published the SCATS and TIRTL statistics online, so people can explore the results directly. You can view the traffic statistics, truck and freight analysis, maps, charts, suburb summaries, corridor findings, methodology notes, and my GitHub code through the links in this video. Now, some people may want the city-wide numbers. Some may go straight to the suburb. Some of you may look at the truck and freight maps. Some of you may want the busiest roads and intersections in Melbourne. Some of you may just want story ideas. Maybe you're a reporter, you want ideas for stories. Some of you might want to inspect my code and the methods behind the work. And that's the point of this release. It's not asking people to accept one conclusion. It's giving people a system that they can explore for themselves. So, if you live near a major road, run a business, care about transport planning, work in media, research, government, freight, logistics, or simply want to understand what's happening across Melbourne, I encourage you to take a look. My name is Clark Towson, and this is my SCATS and TIRTL Traffic Intelligence Project. It all started with a very simple question. What does the data actually show? Now the answer is starting to become visible. Melbourne's traffic story should not only be told by press releases and project brochures, it should also be told by the data.